This is 9-3's homework assignment. We're on page 540. We are starting on number 2. We're going to be using the formula for an automobile stopping distance that's given to us. So we're going to find the stopping distance for a car traveling 45 miles per hour. And so you can see D is distance. That's going to be the stopping distance. So X is going to represent how fast you're going. You run it through this formula at whatever speed you're traveling, and it's going to tell you how much distance the car will travel while it is stopping, or how long it takes to come to a complete stop. So we're going to go ahead and take this equation, D equals 0.05 and times x squared. So x is going to be 45 squared plus x, so also plus 45. And we're going to run this through. Now, if you plug it all in the calculator, it should be fine if you do everything right. But let's make sure we could do this one step at a time if we had to. We've got to follow our order of operations, which means exponents first. So 45 squared gets me 2025. So it's going to be 0.05 times 2025 plus 45 at the end. So 2025 times 0.05 gets me 101.25 plus the 45 gets me my final answer of 146.25. So number 3 is similar, just for 55 miles an hour. So I'm going to go ahead and plug this in. 0.05 times 55 squared plus 55. Now this one, let's try and plug it all in at once. So 0.05 times 55 squared plus 55. And the calculator will get it right for us. So D equals 206.25. Okay, number 4, true or false? The stopping distance for a car traveling 50 miles per hour is exactly double the stopping distance of a car traveling 25 miles an hour. So if it's going twice as fast, is it going to take exactly twice as far to stop? That's the question. So let's just run these both real quick. 0.05 times 50 squared plus 50. 0.05 times 25 squared plus 25. So the number we're inputting is twice the size, the 50 compared to the 25. Let's see if the result is also twice the size. So let's just run it through the calculator. 0.05 times 50 squared plus 50. It's going to take 175 feet to stop. Over here, if you're traveling 25 miles an hour, 0.05 times 25 squared plus 25, you get 56.25. And so is this twice the amount? So if I double 56.25, I do not get 175. So true or false? The stopping distance is exactly double. This is false. It's more than double. So just because the speed is double, it's actually going to take even longer to stop, not exactly double. Number 5. So given this equation, it is in the form ax squared plus bx plus c. If you notice, I have the x squared part right here, so in front of it is a. I've got the x, so in front of it is b. I don't have anything else added, which means c is 0. So a equals b equals c is 0. A is 0.05, and b is the coefficient of x, and since you don't see one, that means it's really a 1. Number 6, explain how you can tell by looking at this equation whether the graph will open up or down. It's all based on A. If A is positive, it's going to go up. If A is negative, it's going to go down. All right, these next couple questions, we've got a bunch to do. So starting with letter A, we're going to make a table of x and y values. it's going to look like this. Going from -3 to +3. All right, so for this equation, we've got y equals x squared minus 6. If you've got the graphing calculator, you can plug it into your y equals and then go to your table and it'll produce it for you. But if you don't, we're just running the numbers through this. Okay, so you plug -3 in, you're going to square it, minus 6, you've got your y value. So when I square -3, that's 9, right? A negative times a negative, so +9 minus 6, it's 3. -2 squared is 4, minus 6 is -2. -1 squared, -1 times -1 is +1 minus 6, that's -5. 0 squared is 0, minus 6 is -6. And now 1, 2, and 3 are going to produce the same answers as -1, -2, -3. Because when you square 1 and the positive 1 and the -1, you're going to get the same answer. If you square +2 and -2, you're going to get the same answer. So 1 squared is 1, minus 6 is -5. 2 squared is 4, minus 6 is -2. And 3 squared is 9, minus 6 is 3. So this right here is our vertex, and they're going to ask us that in a second. Because as I go both directions from there, I have similar y values. Okay, so that shows you the parabola there. Part B, graph the equation. So just a quick graph here, doesn't have to be perfect. -3, -2, -1, 1, 2, 3. We're going all the way up to +3 and -6. So -3, 3 is going to be up here. -2, -2 is down here. -1, -5. 0, -6. 1, -5 starts to go back up. 2, -2. And 3, 3. So you can see this is going to be a parabola that swoops down. Our vertex is right here at -6. And it's going to look like that. Okay. See, we're going to identify the y-intercepts and x-intercepts. So let's start with the y-intercept because we already have that. It's right here. Okay, and that's going to be the point 0, -6. So you could just say the y-intercept is -6. You don't have to give the whole point. So the y-intercept is -6. Now, it's the y-intercept when the x is 0. So if I plug in 0 for x, what I get for y is -6. The same holds true for the x-intercept. Okay, this is when y is 0, because if I found these up here, you look, it doesn't look like it's going to be a perfect number, right? It's not going to be a whole number. But at these 2 points, the y value is not positive or negative, it's 0. So what we want to do is we want to plug 0 into this equation. So we're going to take 0 in for y and solve for x. And so what we're going to do is we're going to add 6 to both sides. We're going to get x squared equals 6. And that means to get x by itself, we're going to square root. Square root of 6 is not a nice number, but remember there is a positive and a negative version. We have 2 intercepts, and so it is square root of 6, the positive and the negative versions. Okay, so looking at this, compared to the answer key had just 6, positive, -6. So that was an error in the answer key. So you need to double check and make sure that you've got the correct answer. The correct answer is square root of 6, not just 6. Okay, we also needed the vertex here. And we've already got the vertex. It was given right here. That's the point where the parabola changes directions. And so our vertex is 0, -6. All right, and letter D. Describe the range of the function. So range, if you remember, range is all your possible y values, and domain is all your x values. So if we are just looking at the range, what are the possible y values? The smallest y value we have here is -6, because -7 is not going to have part of this function. And then these go up forever. So everything above -6 is part of the range. So y is everything greater than or equal to -6. All right, we're going to do the same thing now for number 8. So letter A, we're going to make the table. Excuse my crazy children screaming in the background. All right, and we're plugging in to x squared minus 2x plus 5. So again, if you have a graphing calculator, you can put this into y equals and then hit table, and it's going to do it for you. Otherwise, you are going to have to plug in. So I'm going to do it once here, and then I'm going to plug it in my calculator because it's easier. So I'm going to plug in -3 for x squared minus 2 times -3 plus 5. So you don't need a graphing calculator. You can do this. Square it. It's positive 9. You can treat this as a negative, and a negative times a negative is a positive. 6 plus 5. Otherwise, you would do 2 times -3, and you get -6, and it would say minus -6. And when we have minus and negative, it ends up plus plus. So either way, we're going to end up with a plus 6 here. So 9 plus 6 is 15, and that's going to get me 20. So if you do have a graphing calculator, if you have one at home or you're using one on the computer, you're going to go to your y equals, and you're going to go ahead and just put in this equation, x squared minus 2x plus 5. And then we don't want the graph, we want the table. So second table, and here's your -320. So -2 you can see is 13, -1 is 8, 0 is 5, 1 is 4, 2 is 5, 3 is 8. Okay, so you can see the vertex here isn't on the 0 for the x values. Where's the point that's in the middle? It's right here because we got 5s on both sides and then 8s on both sides. So this right here is our vertex. This is something important. This is when the x value is 0. This is our y-intercept. Okay, so we'll use both of those in a bit. Graph it real quick. 1, 2, 3, 1, 2, 3. Got to go all the way up to 20, so I'm going to count by 5s. 5, 10, 15, 20, and I'll label it. Oops, 10, 15, 20. So -5, -10, -15, -20. And these will count by 1s. You can label it if you want, you don't have to. If you label it, if you're counting by something other than 1, you probably should label it. So -320 is up here, -2 13's in here, -1 8's in here, 0 5 here, 1 4 still a little lower, and now we're back up 2 to 5 and 3 to 8. So this parabola is kind of flat, right? It's not too steep, and it's going to continue going mirror image on that side. Okay, mirror image on both sides of that vertex. And that line that creates the mirror image is your axis of symmetry, which is just x equals 1. The line x equals 1 there is your axis of symmetry. All right, that's part B. Letter C, our y-intercept, that's when x is 0. Okay, where does it hit the y-axis? When x is 0, so our y-intercept is 5. What about x-intercepts? You could start plugging in for y and try and solve this. You probably don't know how to do that, first of all. And second of all, if you just look at the graph, is this ever going to hit the x-axis? The answer is no. It's going up forever. Okay, so there are no x-intercepts. It never hits the x-axis. Vertex we already identified is 1, 4. And letter D, describe that range. Okay, the lowest point for our y values, remember range is your y values, your lowest point on your y is 4, and then it starts going back up to 5. So our y possibilities here are every number that's greater than or equal to 1. There's no negatives. 0 is not a part of this function. 1 is included, so we need the equals, and then everything greater than. Okay, number 9, last one of these. So we're going to make our XY chart. If I was plugging in, I'm going to square it first, then times it by 3, then add 4. So negative 3 squared is 9, times 3 is 27, plus 4 is 31. Negative 2 squared is 4, times 3 is 12, plus 4 is 16. Negative 1 squared is 1, times 3 is 3, plus 4 is 7. 0 squared is 0, times 3 is 0, plus 4 is 4. 1 squared is 1, times 3 is 3, plus 4 is 7. Okay, so you can start to see this is going back up. 2 squared is 4, times 3 is 12, plus 4 is 16. And so you can use symmetry to say, okay, here's my vertex, and then my y values are going to be the same as I go away from it. So 7s, 16s, I know this one's going to be a 31. Part B, quick graph. 1, 2, 3, 1, 2, 3 for my x values. I'm going to go 5, 10, 15, 20, 25, 30, 35. 5, 10, 15, 20, 25, 30, 35. So negative 3, 31. So let's label this 25, 30, 35. So that's going to be up here. Negative 2, 16. Negative 1, 7, 0, 4. And then 1, 7 back up. 16, 31. See, our y-intercept also happens to be our vertex. Y-intercept, where it hits the y-axis, is 0, 4, so y-intercept's 4. Our x-intercept, this is never going to hit the x-axis. There is none. And our vertex, the actual point, we need the x and the y value right here, 0, 4. And letter D, our range. So all our y values. Our lowest y value is 4. It is included, and everything greater than 4 is part of our range. So we're going to write it as y is greater than or equal to 4. All right, I'll double check our numbers here. Okay, we're going to 11, and then 13 to 17. So we are on number 10. All right, the parabola at the right contains these two given points. And the vertex, they tell you, has integer coordinates. So integers are whole numbers. So we know that our vertex here is not a decimal. It's not a weird number. They're telling you it has integer coordinates, whole number coordinates at the vertex. So this hits exactly at that point, the whole numbers that make that up. So if we're going to find the coordinates of the vertex, it's right here. Since we know it's whole numbers, we can just line it up. X value is negative 2, and the y value is 1. So it is negative 2, 1. That's the coordinates of the vertex. And then part B, the axis of symmetry is the line that cuts this into two symmetrical sides. Okay, and any line that goes straight up and down and hits the x-axis, the form of that equation is just x equals. No matter where I go, the x value is the same on that line, and that value is negative 2. And number 11, looking at this table, what are the coordinates of the vertex? So part A, we're looking at coordinates. So if we're just looking at a table, we have to look at where this starts to mirror itself. So if you look, I've got the 36, and then on both sides of it is a 32. They've already told you this is a parabola. So once we identify that it's the same on both sides there, we know that this right here is the vertex. Both of these sides, even though we're missing everything else here, is going to be the mirror image, symmetrical to the other side. So my vertex is that kind of like a midpoint. Negative 4, 36. Then it says use symmetry to fill this in, basically. Find the missing coordinates whose y values aren't there. So they do want the coordinates, not just the y values. So when you look at the key, that's why. So I've got -2 something, I've got -1 something, and I've got 0 something. When they ask for the coordinates, you need the x and the y, not just the missing y values there. So if this is going to be a mirror on both sides, I've got 32. So my next one's going to be 20, and then 0, and then -28. So 20, 0, -28. All right, we skipped 12, and we are on to 13. So which of these two graphs represents this equation? So if you look, both of them are positive, so that doesn't give it away. Our a here is +1, so we know that this should be opening up, so that doesn't help us solve this. If you look, they both have the same intercept, y-intercept here. But one of them is on the left side of the y-axis, and one of them is on the right side. Okay, so which one of these actually fits this? So what you want to do is you want to test a point, an x value, and see, does it match this or does it match this? You wouldn't pick 0, 8 because 0, 8 is going to work for both of them. So we need to find a point that's going to be different. So for instance, right here, this to me looks like a really easy point to choose because I know if I plug in +2, okay, I should get y equals 0 if it's this graph. If I plugged in +2 for this graph, it's going to be a really big number. It's going to be way up here. So that's just a simple test to plug it in. So if I go ahead and put 2 in, 2 squared is 4, minus 6 times 2, so 6 times 2 is 12. So it's 4 minus 12, that's -8, plus 8 is 0. So for this equation, this graph, when I plug in x equals 2, y has to be 0. So that fits B, and that's the correct answer. Justify your answer, so show what we did real quick. Y equals 2 squared minus 6 times 2 plus 8. Y ends up equaling 0, so you have the point 2, 0 on the graph. All right, home stretch. All we got to do here is match. So I'm going to have 14, 15, 16, 17. And we're just going to be putting the letters that match it. So first of all, when I look at these 4 graphs, I see one that is way different than the others. So number 15 is opening down, which means the A value in the A, B, and C is negative. So when you look at these 3, the only one that has a negative A value, negative coefficient for x squared, is letter D. So letter D goes with 15 because that one is opening down. All right, when I look at 16 and I see the point 0, 0, I only see one of these that's actually going to happen. If I plug in 0 for x, I should get 0 for y. And that's going to be right here because you plug in 0, it gets squared, it's still 0. You multiply, it's still 0. And these other ones, you're doing all that, but then you're minusing 1, and then you're adding 1, and you should start to see those clues right here. But the one that's going to produce a 0 on the other side is letter A, so 16 is A. And let's stay with these points. If I plug in 0 here, square it, it's still 0. Times it by 2, it's still 0, but then I minus 1, and I'm going to get -1. So when I plug in 0 for x, I get -1 for y. That would be letter C, so 14 is C. And then if you look at 17, it's going to fit right here because it's the same thing, but after I get all those zeros, when I plug it in, square it times by 2, I'm going to add 1. Okay, so I end up with 0, 1 as my answer there.